Bismillahirrahmanirrahim. In the name of Allah, the most beneficent and the most merciful. Assalamu alaikum, students. Welcome to your new class, ninth junior. Definitely, you must be excited. Yes, you should, as now you have ultimately reached a very, very important class of your educational experience, a first stepping stone of your future career, and hope that you will take this class seriously and spend your time wisely. Unfortunately, students, due to COVID problem, we can't have regular classes as in the past, but inshallah, we'll improve and soon we will meet and study together in a regular classroom. So all the best for the coming days, and one last and most important advice for you: be attentive and regular so that you can study better. Welcome to your lecture 21, and we have started our ninth junior from chapter 5. Chapter 5 is about the factorization and all the topic we have done in class 8 of chapter 6 about the factorization and the formulas. You see one by one that in each question we use the previous formula 6 that we have done in 6.2, 3, 4 and all the 6 chapters. There is the definition of factorization. If a polynomial px is expressed as px is equal to gx and hx, gx and hx, they are the factor of px. Then each of the polynomial is called a factor of px. For instance, in the distributive property, ab plus ac, a into b plus c. Here we take a as a common term. A and b plus c are the factor of ab plus ac. It means that factorization is the procedure in which we convert one polynomial in the product of two polynomials. So this method is called factorization. In exercise 5.1, we have 5 questions, and all the questions has almost 4 to 5 parts, and in some questions there are 6 parts. Question number 1, and all the questions are about the factorization. In question number 1, we use the type of Ka plus Kb plus Kc, and you have done this type in 6.2. In the previous book, class 8, we have done this type in 6.2. 3 terms or 4 terms are given to us, only we see that which variable or which constant or which coefficient is common, and we take common and we convert the polynomial in the form of two, in the product of two polynomials. In the first part, we see 2abc minus 4abx plus 2abd. You see clearly that 2ab is common in all these 3 terms, so we take 2ab common. The rest of the terms, the first term will c will be left in the first term, minus 2x will be left in the second term, and d will be left in the last term. So the complete factorization of 2abc minus 4abx plus 2abd will be 2ab into c minus 2x plus d. Second part, 9xy minus 12x square y plus 18y square. Now y is common, and also in 9, 12 and 18, 3 is a common factor in between these 3 terms. So we take 3y common. The remaining terms will be left in the bracket. In the first term, 3x will be left there. In the second term, minus 4x square, and in the last 6y will be left there. Our answer will be 3y into 3x minus 4x square plus 6y. Because there is only one term common, so that's why the product of two polynomials in which the first term only the one term and the second within the bracket there are 3 or 4 terms. minus 3x square y minus 3x plus 9x square y. In this, we also take minus sign common. It's up to you. If you don't want to take negative sign common, then the sign of the terms will be unchanged. But when we take negative sign common, then all the sign of the terms will be changed within the brackets. You have these practice. When we take negative sign common, then the sign of the bracket will be changed. Minus 3x is common over there. Xy is left in the first, plus 1 is left in the second, and minus 3y square left in the third term. I told you we take minus 3x common, so that's why all the sign of the term within the brackets will be changed. If you don't want to take negative sign common, then your answer will be 3x into minus xy minus 1 plus 3y square. It's up to you. Come to the fourth part. 5ab square c cube minus 10a square b cube c minus 20a cube b c square. When you are taking the common variable in the brackets, we always see that the lowest power of the variable. We take common the lowest power, the smallest power of the variable which we take common. In first term a, the lowest power of all these terms is only a, and the lowest power of b is b, and the lowest power of c is c. It means that we can take common a, b, c. Now come to the coefficient 5, 10 and 20. 10 and 20 are the factors of 5. So definitely we take 5 common. 5abc is common. Left of the terms are bc square minus 2ab square minus 4a square c. This is the answer of the factorization of 5ab square c cube minus 10a square b cube c minus 20a cube b c square. The fifth part is 3x cube. Now this part 5 and 6, they both are a little bit different from the previous part. 3x cube y into x minus 3y and minus 7x square y square into x minus 3y. The type of the question is changed, but the method will be same. Now you see clearly that the bracket numbers x minus 3y, they both are common. We take common x minus 3y, the remaining terms will be 3x cube y minus 7x square y square. But in the second bracket, 3x cube y minus 7x square y square, there is also x square y common. So again, in the second step, we take common x square y only from the second bracket, because already the first bracket factorization is completed over there, x minus 3y, no element is common over there. Only in the second term, in the second bracket, we take x square y common, and now our answer will be x square y. We rearrange the terms, x square y into x minus 3y into 3x minus 7y. The same procedure we will adopt in the sixth part, because the nature of the question is same that we have done in part 5. X square plus 5 is common. The remaining terms are 2xy cube plus 8xy square. Now again in the second bracket we see 2xy square is common and y plus 4 will be left there. For our answer, rearrange the terms. First we write 2xy square, then x square plus y, and then y plus 4. This question was too much easy because we have already done in the previous class, and only we take one term common, and in the one step we have completed the factorization. Now come to the question 2, and I think that you recall your previous knowledge and you see that this is the type of the questions that we have done 6.3, where we 4 terms are given and we make the partners of 2 terms, then we take common. And at the end, the last third or fourth step, we got over complete factorization. In type 2, we have, you see, AC plus AD plus BC plus BD, these type of the term. I means in the polynomial, four terms are given to us and we make the partner according to our requirement. Yes, part 1 is 5ax minus 3ay minus 5bx plus 3by. Now, according to our demand, we combine first and the third term and we make the partner of second and fourth one. We enclose within the brackets 5ax minus 5bx and in the other bracket minus 3ay plus 3by. Always remember that when you are rearranging the terms or when you are making the partner, you always put the positive sign in between the brackets. You always put the positive sign within the brackets. In the first bracket, 5x is common. The left terms are a minus b. But in the second term, in the second bracket, minus 3y is common. Minus 3y is common. So we take minus 3y common. The remaining term is a minus b. Now the same that we have done in the sixth part of the previous question, we take a minus b common and 5x minus 3 will become the partner. Now our factorization will a minus b into 5x minus 3y. I think that you recall your previous knowledge. Yes? Good. The second part is 3xy plus 2y minus 12x minus 8. In all these questions, in all these part of question 2, four terms will be given to us and we make the partner 3xy minus 12x. We combine these two and 2y minus 8. Always remember which sign we put within two brackets? Positive sign. Good. Now from the first bracket 3x is common, y minus 4 and in the other bracket 2 is common and my y minus 4 is left in the second. Same y minus 4 in both the terms. So my y minus 4 and 3x plus 2. We convert 3xy plus 2y minus 12x minus 8 in the product of two polynomials y minus 4 into 3x plus 2. Third part is x cube plus 3xy square minus 2x square y minus 6y cube. Again the same procedure, we combine the partners, we make the partners within the brackets and we see that which elements are common in the brackets and we took common from the first and second bracket. In the first bracket, x is common. The remaining terms will be x square plus 3y square. And as I told you that in the first step, you always put the plus sign in between the two brackets. And in the next step, you see that whether any sign is common in between them or not. So minus 2y is common and x square plus 3y square. By mistake, I write here minus. It must be 3y square because the sign of the both brackets will be the same. Okay, x square plus 3y square and the second bracket. The sign and the power of the variable will always be same. By mistake, I write here x square minus 3y square. This is x square plus 3y square definitely. Okay. Now x square plus 3y square is common and x minus 2y will be left in the second bracket. Come to the fourth part, x square minus y square z plus y square minus z square x. Already they have the partners x square minus y square, z and x. They both are outside the bracket. For this question, first we multiply the variables within the brackets and then after multiplying, we make the partner and then again we factorize the terms. So for in the first step, we multiply z with x square minus y square, x square z minus y square z. The next bracket, when we multiply it with x plus y square x minus z square x. Now, according to our requirement, we make the partners x square z. We combine x square z and minus z square x. The remaining two terms y square x and minus y square z, we enclose them within the second bracket. In the first bracket, clearly xz is common. The left are x minus z. Same in the second one, y square is common, then x minus z is left. So x minus z and xz plus y square is the required answer of our question. In this part, we have completed our question 2. Come to the question 3. A square plus 2ab plus b square. A square minus 2ab plus b square. All of you are familiar to these formulas because you have done in class 7th and also in class 8th. And the same formulas we are using in 5.1. So only this is your previous knowledge. Question number 3. There are 4 parts in question 3 and they are regarding these two formulas. We put a plus b whole square and a minus b whole square. Do you remember that when we are simplifying the terms of these type of the question, first we see that what is the first term. The first term is the square of which number, and also the last term is the square of which number, and then we take the half of that numbers and we can convert in the form of a square plus 2ab plus b square, which is equal to a plus b whole square. Now you see in this part 144, and 144 is a square of which number? 12. You have the calculators, so you take the square root of 144 and you get directly the value of the square of 144, the under root of 144, which is 12. So instead of 144 a square, we write here 12a square plus 2 into 12a into 1 plus 1 square, because we have the formula a square plus 2ab plus b square. And in our question, a is 12a and b is 1. So that's why instead of a, we put 12a, and instead of b, we write there 1. 12a square plus 2 into 12a into 1 plus 1 square, and this is equal to a plus b whole square. Because a is 12a and b is 1, so we enclose 12a plus 1 whole square. According to the definition of the factorization, we write 12a plus 1 whole square in the form of product of the two. So we split 12a plus 1 whole square as 12a plus 1 into 12a plus 1. In the last step, only we split 12a plus 1 whole square in 12a plus 1 into 12a plus 1. Yes, the next part of this is a square over b square minus 2 plus b square over a square. There is negative sign in the middle term. It means that in this question we will apply the formula of minus. A minus b whole square is equal to e square minus 2ab plus b square. According to our question, a square is a square over b square and b square is b square over a square. So when we put the values in the formula, instead of a, we write a over b whole square minus 2ab plus, instead of b, we put there b over a whole square. So when we enclose in the formula, we write a over b minus b over a whole square. And again we split the power. 2 is given, so it means that we can write ab minus b over a 2 times. A over b minus b over a into a over b minus b over a. The third part of this question is x plus y whole square minus 14z into x plus y plus 49z square. According to our question, a is x plus y and b is 7z because 49z square is given and 49 is the square of 7. It means that b is 7z and a is x plus y. Now we put the values in the formula. There is negative sign in between the terms. It means that we will apply here a minus b whole square, which is equal to a square minus 2ab plus b square. As I told you that a is x plus y and b is 7z. So simply you will put the values in the formula. Instead of a, you put x plus y, and instead of b, you write 7z. X plus y whole square minus 2 into x plus y into 7z plus 7z whole square. A square minus 2ab plus b square. So when we combine the terms, it will be x plus y minus 7z whole square, because this is a minus b whole square and a is x plus y. So no change in the sign of x plus y. It will be same, a minus b whole square, and there is a square, so we split it, x plus y minus 7z into x plus y minus 7z. Students, because we have already done in the previous one, so that's why this is only the review of your previous knowledge. 12x square minus 36x plus 27. 12 is the square of which number? Who will tell me? 12 is the square of which number? Can you find the number? No. Same, we cannot find any number. The square of that number is 27. It means that maybe any number is common in between these terms. When we take common, maybe the remaining terms will be the square of any other number. In 12, 36 and 27, we can take 3 as a common number. The remaining terms will be 4x square minus 12x plus 9. Now you see easily that 4 is the square of 2 and same 9 is the square of 3. After taking common, we can find the terms which are the square of the numbers. Now 4x square, 4 is the square of 2. So instead of this, we write 2x whole square minus 2ab, 2 into 2x plus 3, 9, and 9 is the square of 3, 3 square. Because there is negative sign with the second term, it means this is a formula of a minus b whole square. So we write 3 because we take 3 common. So in our answer we must write 3. You cannot omit 3 from the steps. 3 will be there. 3 into 2x minus 3 whole square. Again we split 2x minus 3 in the form of 2x minus 3 into 2x minus 3. Question number 3 is completed. We apply there a plus b whole square and a minus b whole square. Now is the turn of the third formula. A square minus b square into a plus b and a minus b, the easiest formula of this exercise. The first part of question number 4 is 3x square minus 75 y square. The same problem is here. 3 is not the square of any number, same as 75 is not the square of any number. It means that again, what we will do, we take common any number and the remaining terms will be the square of any other numbers. 3 is common in x square, 3x square minus 75 y square. When we take 3, the remaining terms will be x square minus 25 pi square. X square is the square of x and 25 pi square is the square of 5 pi. Directly you will apply here the formula x plus 5 pi and x minus 5 pi. 3 into x plus 5 pi into x minus 5y. The second part is x into x minus 1 minus y into y minus 1. There is no square, so how can we apply the formula of b square minus b square? But you see that there is x before x minus y and there x minus 1 and y before y minus 1. So first we open the brackets, we multiply the variables within the brackets, and then after opening the brackets we make the partner and we apply the formula over there. When you multiply x with x minus 1, x square minus x, and when we multiply minus y with y minus 1, because there is negative sign with y, so when you multiply or open the brackets, the sign of the brackets will be changed, minus y square plus 1, because there is negative sign with minus. Now we have x square minus y square minus x plus y. After rearranging the term, when you open the brackets, we got the values x square minus x minus y square plus y. I just told you that when we have a negative sign before the brackets, after the multiplying, the sign of that bracket will be changed. Minus will be changed into plus and plus will be converted into minus. We arrange the terms x square minus y square will be the partner and the remaining terms will be x plus y and they also enclose within a bracket. X square minus y square, and when we take negative sign common, x minus y will be left within the bracket. X square minus y square, now only we can apply the formula on the first bracket, because in the second bracket the power of the variable is 1 so no need to apply the formula over there. X square minus y square, x square is the square of x and y square the square of y definitely. So after applying the formula, the terms will be x minus y into x plus y minus x minus y. Now we have two terms. In the first term, there is a product of two numbers x minus y and x plus y, and the second term is only x minus y. And you see clearly that x minus y is common over there, so we take x minus y common. The left of the term in the first one is x plus y and in the second is minus 1. So our required answer will be x minus y into x plus y minus 1. Third part is 128 am square minus 242 an square. The same problem is here that we see in part 1, that 128 is not the square of any number and same 242 is not the square of any number. It means that maybe there is some number common. A is also common over there because the power of A in both the term is AA. So the power of A is 1. So we take A common, and also we can take 2 common from both 128 and 242. When we take common 122 from 128, 64 will be left. And you know that how we can take common. You divide 128 to 2. and the quotient will be your required number. After dividing 128 to 2, the quotient will be your required number, which is 64. Same, you divide 242 with 2 and you get 121. 64m square minus 121m square. Now 64 is the square of which number? 8. And 121 is the square of 11. 8m square minus 11n square. According to the formula a plus b into a minus b, it will be 8m minus 11n and 8m plus 11n. The last part is 3x minus 243x cube. We take 3x common. The remaining terms will be 1 minus 81x square. 81 is the square of 9 and 1 is the square of 1 itself. 1 square minus 9x whole square, when we put in the formula 1 minus 9x and 1 plus 9x. In question number 5, this is same that we have done 6.6 in class 8th or in the midterm 6.6. Here we combine the two formulas a plus b whole square or a minus b whole square with a square minus b square. First we apply the first formula a plus b whole square and then we apply the second. In the second step we apply the formula a square minus b square. We have in question 5 6 parts and you clearly see that you can combine the terms in all the questions. X square, the first part is x square minus y square minus 6y minus 9. 4 terms are given and this is not same that we have done question 2. This is totally different. In question 2 we have 4 terms and we combine the 2 terms, we made the partner and then we factorize it. But here we have 4 terms but 2 terms are in the form of square, x square and y square, and also the third term with the variable y. It means that you always combine the constant term with that variable which are 2 times in the question. As in part 1, you see x square only once, x is only once and y is 2 times, y square and minus 6y. It means that we combine 9 with y square and 6y. 9 will be the partner of y square minus 6y. Because when we have the formula a plus b whole square or a minus b whole square, we need 3 terms. So that's why we combine here y square minus 6y and 9. We make the partner of these 3 terms and x square will be the separate one. In the second step, when we apply the formula a square minus b square, when we will use x in that formula. Yes, x square and y square plus 6y plus 9. Because there is negative sign with y square and according to the formula, there must be a positive sign with the square. So that's why we take negative sign common and you see y square plus 6y plus 9. Now all the signs of the terms become plus. It means that we will apply here a plus b whole square. Y square is the square of y and 9 is the square of 3. Y square plus 2y into 3 plus 3 square, and this is equal to a plus b whole square. In our question, a is y and b is 3. So we write y plus 3 whole square. Now clearly the question become in the form of a square minus b square. The first term is x square and the second is y plus 3. When we apply the formula over there, a plus b into a minus b, because the second term is within the bracket, there are 2 terms in the second one. So first you write within the square small brackets, and in the last step you open the brackets. X plus within the bracket y plus 3 is there, and then x minus within the bracket y plus 3, because when you apply the negative sign then it will be uh, the change will become in the sign. So you should be careful when you apply the formula. First you write within the brackets, and in the last step you open the brackets, because there will be no mistake of sign over there. X plus y plus 3 and x minus y plus 3, and you see in the second bracket when you open the brackets the sign of y and 3 they both become negative. So you should be careful when you are applying the formula a square minus b square. The second part of this question is x square minus a square plus 2a minus 1. So definitely there are 2a in the question. It means that the constant term will be the partner of a. Again x square is left alone, and a square plus 2a and 1 they become partners, and they make the formula of a minus 1 whole square. Again a square minus a minus 1 whole square means a square minus b square. Now in our question, b is a minus 1. Now we apply the formula a plus b into a minus b. Again x plus within the bracket we write a minus 1, and then when we start the second bracket for a minus b we use the square bracket, and within the square bracket we have x minus a minus 1. Now in the last step you will open the brackets with signs, and x plus a minus 1, and in the second bracket x minus a plus 1. All the question of all the parts of this question are same, but you must be careful. I'm telling you again and again. You see that which variables are repeated in the question. The constant will always be the partner of that variable. In the third part, again 4x square minus y square minus 2y minus 1. We have y square and y. It means that 1 will be the partner of these two terms. And again 4x square is left alone. We combine y square, 2y and 1 because there is negative sign with y square. So according to the rule, you must take negative sign common, and within the brackets y square plus 2y plus 1 will be left. And this is the formula of a plus b whole square, because all the sign are positive, y plus 1 whole square. And 4x square, when you convert in the form of the square, 4 is the square of which number? 2. So instead of 4x square, we write 2x whole square minus y plus 1 whole square. And this is the formula of a square minus b square. It will be a plus b and a minus b. Again, when you open the brackets, 2x plus y plus 1 and 2x minus y minus 1 is the required answer. Fourth part is little bit change from the above parts, because 5 terms are given there, and also x is repeated and y is repeated. We cannot make 3 the partner of anyone, not x, not y. Because if we make the partner 3 with x, then 3 terms will be complete of x, but y will be left there. So to complete the formula, we need 6 terms. We combine 3 terms x and 3 terms of y. So we split 3 as 4 minus 1. Although there are many factors of plus 3, but the requirement of our question is that we split 3 as 4 minus 1. Now, after writing this, you see that how many terms you have in your solution. There are 6 terms: x square, y square, 4x, 2y, 4 and 1. Now, you see the coefficient of x square is 1, but with x there is 4. So it means that we combine 4 with the x and 1 with y, because the coefficient of y square is 1 as well as the coefficient of y is 2. So we write 1 with y square and 4 with x square. After making the partner, enclose them within the brackets. You see x square minus 4x plus 4 and y square plus 2y plus 1. But according to the rule, because there is negative sign with the y square, so we must take negative sign common, and the remaining term y square plus 2y plus 1. The first bracket become the square of x minus 2 whole square, and the next bracket will become the square of y plus 1 whole square. Again we have a square minus b square. In our question, a is x minus 2 and b is y plus 1. Excuse me. When we open the brackets, we got x minus 2 minus y minus 1 and x minus 2 plus y plus 1. Now you rearrange the terms x minus y minus 3 and x plus y minus 2. Fifth and sixth part, they both are same, that we have done 1, 2 and 3 part. Only fourth part is little bit changed from the remaining. Only we convert 3 in the part of 2 terms. You see here 25x square minus 10x plus 1 and z square. Two variables are involved in part 5, but x and x. Only z is different, separate. It means that we combine 1 with x. 25x square minus 10x plus 1. We enclose these three terms within one bracket, and 36z square will be left because there is no partner of z in the question. The first three terms, 25x square minus 10x plus 1, when we simplify it will convert the formula of 5x minus 1 whole square, because 25 is a square of 5x and 36 is the square of 6. 5x minus 1 whole square minus 6z whole square. Again apply the formula of a plus b into a minus b. Writing the values, open the brackets, you got the answer 5x minus 1 plus 6x and 5x minus 1 minus 6z. The last part of this question and also the last part of this exercise is x square minus y square minus 4xz plus 4z square. Now you should be careful about the terms. You see that there is one term of x square, one term of z square, and the middle term is the product of x and z. It means that now we have the partners in this question x square, 4xz and 4z square. These three terms will be the partner and the left term will be minus y square. We apply the formula of a minus b whole square on x square minus 2x 2z plus 2z square, and y square will be left. But the negative sign with minus y square, so you must write minus y square. It doesn't mean when you change the position of the variables that you cannot change the sign of that variable. You see that we combine x square minus 4xz and 4z square. 4z square comes on the place of minus y square, but the sign of 4z square will be the same, and the y square have the negative sign. You cannot replace the signs. The signs must be same. Now the first three terms, when we combine then apply the formula, it will become x minus 2z whole square and minus y square. A plus b into a minus b, x minus 2z plus y and x minus 2z minus y. After opening the bracket, we have x minus 2z plus y, x minus 2z minus 5. Students, 5.1, all the parts, all the questions are the review of your previous 6 chapter. If you have the difficulty, if you have any problem in any question, you will note down it and you can discuss with me, and you must do the practice of 5.1 from the beginning. If you do your work daily, then it will be easy for you to understand the next exercise because all the exercises are based from the previous one. Inshallah, we will meet again. Allah Hafiz.